Hello fellows, this is Pxy-STUDY. We are back with this thing where this time I want to complete it. This first version of this collaborative project of rigging, and in principle start with organic rigging, then with the control rig, right? So the thing here is that we have some, I hope the sound is working because I'm trying to. Tell me please if someone is watching right now, if the sound is confusing. I'm not using a headphone, I'm trying to get the sound from a YouTube soundtrack and at the same time use the microphone as an isolated way so that my voice is heard without conflicting too much with the soundtrack. I hope it's fine, that you can hear both the music without double music, distorted double music, and without making my voice or the music unhearable. Alright, so here we, anyways, I'm gonna check later on. I don't have time to make these tests here, so let's continue here. So these are the fan bone systems, these ones. I need to make sure that they are actually automating with and that they have the proper waves. So to start with, I know that these ones don't have the right waves, they are waveless, so because they are new ones, although all the rest is apparently working and we might not have to fix them anyhow. No, there is something about this bone that maybe... No, this is the final pose that I decide for it. You see, so some of this affects more of this mesh and this one on the previous, that's why. So they are dual fan bones set up, and these waves, they can be very exacting because they can represent the same waves of the skeleton bone, like with subtraction. So you'll see what that means, for example, and we can do this in a very calculated way. Of course, this is not sufficient to solve artifacts sometimes, like not in a complex joint, but doing this makes things much more easier instead of having some random waves, manual waves. No, this is very, you can do manual waves for the base bone, right, somehow, but then for this one we can have exacting. In the beginning I wasn't doing exacting waves, and then yeah, it worked, but this is even better because the functionality of the fan bones, at this simple fan bones, is the derotation of the mesh. Right here might have a problem because these bones, there are just not enough mesh here, but here is the joint, is not exactly about this joint, so we're gonna try to ignore this thing. Okay, so I want to get I say that this seems to be wrong, right? Because this bone, actually we want to include a few more joints here, right? Actually what I mean is that we'd like to this is a base deformed skeleton thing, so we want to be able to expand a little more this thing. Yeah, so we're gonna just wave paint this. Not sure we can use this. This is a mistake. Okay, this is better. Now alright, and because the joint is here, we're gonna just smooth here on the back part. Yeah, this topology, we could do a better job with for this kind of thing, but it's not very easy now to do these waves. I'm still investigating. If we want to rig this, yeah, in the end I want to have the naked feet, right? Naked foot with all the limbs, right? The toes, not something like this. So it will be more work, right? But for now we are making this simplified. Okay, so this will symmetrize in both directions. Let's see. Okay, now this is much better. So what was happening is just a stupid wave. Okay, this is just that's good. Okay, so now for the fan bones. So this was a revise, so let's get this fan here and they form skeleton. We see that the position doesn't seem quite right. There is an offset, of course. Because of this, we might have to change the strategy here. It is kind of new. Should we have a fan bone here and there? Yeah, this is not. This was a split. I don't like this. So why this? Because this is not a wrist, right? Maybe I could just have ignored this one. Well, we'll try. If it still, if this works for both, maybe it needs to activate. It'll be weird, maybe. Yeah. Anyways, gonna see what we can do. So here, this one has got some waves. We want this vertex group. This also doesn't feel quite right. We're gonna expand this. I'm doing this in the mouse. It's not even... Yeah, it doesn't need to be too much accurate here. As for the inner part here, I believe it's adequate that we also make the includes this. Really? Yeah. Not really sure. Let's just do this. So there are many wave paint strategies, but in this case, yeah, let's do this, right? Like we have this. I like to expand, but let's Okay, so we have this wave here. We need to access the vertex group panel. So it's precisely this one, and what we do now is that this bone has no waves. So we're gonna find it, we're gonna duplicate this thing, like copy, duplicate, and so now we have a copy just on the other side. We cannot pick the bone's name, and so this is a problem. Maybe we can cheat here. We're gonna copy from here, and we're gonna remove this. It's very weird, right? Because it's already created. Now we cannot remove this, so okay, let's do Ctrl Z here. So I don't want to create these vertex groups. I just want the name of the bone, so we need to go back to here. Now we find that copy, and here we paste the period key doesn't work for that. So what we have here is that these bones now have the same waves, but this is a helper bone. So what I'm gonna do here is that we're gonna take off how do you do this? Okay, we're gonna expand the selection here until here, and now what we're gonna do, we're gonna subtract. There's no waves there, right? It would be rogue waves. So this is just a selection, but what I want is this from here, right? And we're gonna erase this, subtract to 0, remove, right? And now this fan bone, it has exactly the same vertex waves as the foot on these vertices, but not anywhere else. So it's the same waves in these vertices. And so what this bone will do is that it will derotate precisely. The problem with this technique is that if we forget something, as I just forgot, we have to remake this stuff. It doesn't need to be equal, but it's annoying, right? So we're gonna, I forgot something here. Fortunately, we can use the mix, and maybe we get the constant fall off. This technique is better for this kind of low poly thing. So with the same wave, I'm gonna do this here and here. Yeah, that didn't actually solve too much things, but okay, let's do a little more than it were. Just reproducing this, okay. And then as for here, we're gonna do the opposite. So we need the name of this bone. Then we get here, we're gonna duplicate. And then we're gonna wait, what? Why do we? Okay, because there is a 001, this is correct. So we want here to duplicate here and then paste. It will recreate, it will generate the other side as well. So here it is. The problem is that, of course, there are too many. We don't want this It's just for the joint, right? So you can remove, for example, all of this. Maybe we could add, so here we can smooth out, like this is doable. I think it didn't do this smooth out in the other case. You don't need to do this, but this is it seems it will be fine. It will be okay. The problem is that I don't have for the thumb, and this bone responds to nothing right now, just to its parent. I'm gonna make a trick to allow it to be manipulated by both one parent and a fake parent. Alright, so what we do here is that I think I'm gonna place its position like here. Just because its position doesn't really matter too much as the proper waves, right? It can be slightly offset. Ideally, we could have another one here and two of them, but this joint doesn't really need all this setup. It's just, yeah, if we could avoid this, it would be better. But I'm just doing this for exercising, like, and see if this setup has any value in the end. For now, it doesn't seem super interesting. And you see that I'm not even using for the bigger knuckles here any of this. This is for the wrist, so it's different. Also, since we are here, let's scale this down. Will make it easier to work with. They don't need to be aligned, right? They can be in any direction. The direction is like the orientation of the bone, right? It can be anything. Anything will work, but we'll have to adapt the automation then for the automation. And to make sure that this bone is just about, doesn't go beyond, right? So we see here that we have a wrong, apparently these placements don't seem quite right. So to solve this, we see that the z-axis is pointing, gonna do this, and then we're gonna do this and reset. Yeah. As for the position of these bones, we're gonna make some change here because I'm not liking this organization here. Yeah, it's wrong to place them here, so yeah, there'll be this thing here. It's very bad. I don't know if this angle means anything. I think this is following the model. Yeah, it's following the model. So this is actually not very good, right? if we pick this, the angle will, yeah, the angle will probably change. Let's see. Yeah, so it's useless to select it. But I think we can do this without too much issues. Is this pointing wrongly? Yeah. I thought I had adjusted this already. No, I remember what was the thing, is that I was doing this with the control rig, but the other rigs, yeah, they also point down. Yeah, so we have some strange offset here. It's not accurate for this joint. No, this is something else still. Yeah, I don't know when did that happen, but it's not accurate. Here we might also have to check. Oh, yeah, this seems right. Also here this seems right. I'm used to do this, but I hate these things in rigging. It's very easy to mess things up and very hard to time consuming and boring. There's just no smart here. This is where AI should definitively do something. Okay, let's go back to the bones. So here, the deformed bones, the helper bones. We don't need this. We just want the deformed bones and also not even the control bones. Okay, so let's go for this bone. Okay, so this is yeah, so for this one we could wave paint here, but I think it's too far, so It's just so this is exactly just a subtraction. Well, this one as for this one we did some smoothing. This sounds very crude. Okay, that is much better. Anything to do on this part? No. So what we could do is to add some this doesn't seem necessary. Sounds a bit weird, so we could just remove. Then here we so this part I'm not really understand what I'm doing. Just want to get some very subtle waves. So this will be mix. This Blender version got this a bit messed up. Now it always starts with the add instead of the mix. Okay, so let's just do this, and so this controls more or less this whole foot. So this is this might cause some bizarre results. We'll see in a moment. So we need now the automation, and we need to just see the parenting that this thing has. So this is parent offset to the target 2 toes left. Yeah, this is correct. The target foot, yes, and the target foot, yeah. So that's fine. So everything, the deformed skeleton is also parented to, for example, this to the target foot. So either we could do instead like make the helper rig parented to the deform rig, but this is, although it might make sense, there are situations where we don't have the deformed bone in a specific position, or it's not advantageous, so it's better to parent it to a mechanism rig or target rig, whatever. I made this a target rig, so with that it's more organized, although it takes more bones, which is it's also safer, because then we have more mechanisms to make the automation work. Now, this is not exactly the case. We just need a higher hierarchy layer for that. So this target rig is the middle hierarchy. And so this is why whichever deform bone that goes to it, then this target rig will try to solve the things. But then it also implies that it has the right relationships with the higher hierarchy, the control rig in that case. So now we need the automations, right? For this kind of setup, I was using a pattern and we're gonna reproduce it. So basically, if we look for here, we'll see that both bones, in spite of the fact that they are facing on opposite directions, essentially, the z-axis, they are matching. And so that means that, yeah, it's the same for here somewhat. And this is a bit easier to make the copy rotation. So you see that this, even the bone constraint goes to, yeah, so in this, for the feet and hand, I had to use a transformation bone constraint because of some specific, I think it's specific to the, yeah, it's because of the Aiki bone constraint, how we need to parent the hand and the foot bones in order to make this Aiki not break everything. So this is the reason. And then the copy rotation bone constraint usually doesn't respond to the automation. It's very weird. So the transformation bone constraint is much better in that sense, but it's harder to configure. This is garbage, but it works. So it's easy to use. It's not totally easy. There's a lot of challenge, but in principle we can do. So you see that this one is not responding. Yeah, so you see that none are responding. So maybe there is something wrong about yeah, I've been using this setup, so add, okay, I'm trying to figure out why it's not responding. I'm using the x-axis and the z-axis, so ignoring the y-axis. Although for twisting, no, these are fan bones, they are not supposed to handle the twisting features. This bendy bone foot, which I don't have here, could handle, but it's not a big deal here. We're gonna skip with the same strategy here, X and Z. And then it's a reverse thing, but it doesn't seem to be. Okay, X and Z, right? So this might not be working because of this target rig is incorrect. Yes, so mechanism Aiki target, right? So control shin. All right. So the thing is that I'm lacking some structure here. As this goes parented to that bone, and this is not parented here, so when I pose this, the parenting relation pathway of transforms doesn't reach this bone. So this wasn't a problem on my other rig because it had more structure. So in here I would have to adapt. So I need to get the parenting here, so probably I can just change the parent here. I hope this won't break the system. But the bone, still, yeah, nothing changed, but even what I wanted to do also didn't change, so this is not good. So it was not exactly what I expected. Yeah, in principle we would like to target, so maybe this shouldn't be a problem here. So maybe we're gonna play with this and see. Maybe there is an inversion here that is needed. Yeah, maybe this thing is placed. Okay, probably is. Well, the problem might just be here. So yeah, because the z-axis here is pointing up, so maybe we just need to, let's see, this is the map from x along local, this is a positive, so if, okay, okay, I think we are not seeing anything. So usually this is done symmetrically, but here it's really not working. So and we need to do the reverse here, so it's a derotation using quaternions. This allows to use quaternion. It takes the quaternion, so I think this matters, but maybe not. Not replace. It will be weird to, maybe I'll have to do this. Let's try. So here it's the okay, to no avail, so nothing, it's probably nothing to do with this. It's still just yeah, so the problem which I don't understand, maybe they changed in Blender 5.0, I don't know. So the thing is that this target bone, yeah, it had, so it's not about this, so I'm gonna remake the parenting here. But what happens here is just that, let's look at the hand, maybe it gives some insight. Parent to the target hand, and we see the same, okay, we're missing a target, which was a mechanism bone, right? Or a tweaker bone, yeah, what this was certainly. I'll try something like okay, the bone is not reacting, so we're gonna try to use this it's not a replace, it's an add thing. So so now it seems to be working. Yeah, we needed to change the target. Now it should also work for this side. There we go. As for here, it's not doing anything, so we're gonna use the same. And you see that this uses copy rotation. So as we make an angle here, you see that this bone try to get here and this one try to get here. So this is correct. They are delaying behind this corner here, the length of these bones, right? And same here, this is lagging behind and this is also lagging behind. So this is working, and it's working all directions. To make sure it really works well, you need to, of course, a lot of tests will be required, but in principle, if you see this is bad. So something here is, I'm not sure if this is because of some maybe it was just a two wrong pose, yeah, that I was doing. But if that happens too easily, then it's because the copy rotation bone constraint, which is pure garbage. So if you use like, there are many local with parents, apparently it looks good, but then it causes double transforms, and there are many situations where it starts to warp like crazy, and it's not because of the bendy. Here might be because of the bendy bone twist that has a limit, but sometimes it's the pure copy rotation, and this one is working. Okay, so I found out the solution here was to not change the parent, although that could also work, of the target hand. We keep the parent, and then we use even though it's offset, right? It's not exactly aligned with it's aligned with the master bone, right? Master hand, but it's not aligned with the deform and helper deform bone. So, but that's okay because it's a parenting relation, and also it's okay because when it comes to the transformation, when it comes to the bone constraint, this is not a replace, this is an add, and even the replace don't seem to do anything here. And here also it's a before original, another replace. So I'm not sure, maybe it would work anyways in this case, but the thing is that it's not overriding, it's just adding up transforms, right, through bone constraints. So that is, in this case, it was possible. Not always it is possible to do in that way. So in order to make sure that we got the things right here, we're gonna just resymmetrize everything here. And here we're gonna check if, so this is a different proposition. So here it's because of the angles, right? So you see that it is working. We could test the other way around, but yeah, I already tested it. See, they are slightly delaying behind on. So this one seems to be working perfectly, and also regarding this, see here, yes, and here too. Very subtle, but we can see. And then finally these ones, but if it's not, let's symmetrize that just in case. Then So these ones are just using the copy rotation because it's easier. And this always depends on the orientation, right? The axis, yeah, the roles, right? How you want to. You can even parent this one, which is less intuitive to make than the single fan bone. You can delete this. You don't need this, but it maybe it's better. My experience, it seems more complete, but you can do with just one. That also helps a lot. Then it can steal some weight from this part. Essentially, this is just maybe a bit more precise, but twice or thrice the headache. I still need to figure out if uh, if we can just handle with this at some point. It just takes. It's very hard to really know in this rigging stuff what is really more elegant. This is why the research. Okay, I'm doing, and it's a collaboration. So let's make other fellows find out, riggers, right? Find out what they can. They have their own ideas, right? So their own setups, and that might be interesting to look at their own systems as well, try to implement them and see if they work better, if they are more efficient, more economic, more cost efficient, more effective, or skinning. All right, so and easier to build also. So here, so it's the elegant thing, effective and efficient. So this we need to test with maybe this one. Let's see. Okay, you see that there is something is going on. It's not sure that everything that is moving here is adequate, but let's see. This is target shoulder parent, okay, and this is target upper arm. That's correct. Then it's target the upper arm, but yeah, you see these ones target a different bone, right? Let's go back here. I have this idea. After I go back to the shoulders because it's a new thing, right? We want the target to be actually this one. Now you see that this is working as expected. The amount of derotation will depend on the wave, the amount of wave, but usually it's about, it's very small. It's a armature deformed corrective method, right? Copper bone. So this is equivalent at 1/3. It's like instead of 90 degrees, it's like 30 degrees. Let's say that it's 1/3 delay. Like if this, it's hard to tell, but this will be an angle of 30 degrees. It looks like 30 degrees because I've rotated this one like 90 degrees. Then, okay, this is as it is. And this has been delayed, like behind, right? About 30% of that, so it's simple, right? Simple math. So the values are everywhere, but I'm used to this, right? So there are various ways to represent this, right? So basically, this one is working. As for this one, we also need to paste the setup here, the target, and now this will delay. This seems not to be quite correct. Because it is moving, that maybe it's a good deform, I'm not sure. So it seems like it's doing the opposite. it's a different situation, right? Maybe because there is already an angle like this, so this can be, it's a little confusing right now. It's because this foot is, this thing is not moving, right? Okay, this might be, okay, it's lagging in relation to a supposedly invisible bone that doesn't exist here, so it's an abstraction. However, if we did that, we just reverse the thing, right? This is increasing the angle, right, of this joint, which doesn't seem right. We want to actually decrease this like here, if we disable it, actually we can see here, yeah. So it's derotating, right? It's doing this and allowing the, so instead of doing this, which will be worse, it is doing this, right? So this seems accurate. It's just bizarre because we have to make this abstract. So if it doesn't have here, then it will be straighter, but right. So what I think I can do here is just maybe reduce this one, right? A little. Okay. So we're gonna symmetrize this, and now we're gonna use this one. So no, we're not yet. We want to check these ones. So it's a copy rotation and a copy rotation. So we're gonna reuse these ones for this setup here. So it's easier to, we don't have to recreate all this garbage. So here we just need to see, we're gonna use this, I guess. Target shin, yeah, and then this one we use this. And maybe also here, wait, target foot. It is parent to target shin. Yeah, so will that work? No, not sure. It's parent to the target for. See, the derotation occur of these bones, even though they have the same parent as the bone constraint. So this is exactly the opposite that I was thinking. So this works maybe with the copy rotation constraint because it's in the middle of the limbs. This area is easier. It's the really complicated things is usually the hands and feet because of the separation of those parts, right? All the mechanisms, it goes nuts. And then okay, so I think what we're gonna do here, since we are using bone constraints, we have this one. Let's try to duplicate this, and we're gonna maintain this structure, right? Just change this parent. This we will test later. Yeah, in order to test this, we'll need this. We see that it's not responding. So this is also not responding to, well, this will never respond to the foot. Actually, hold on. We need actually to target the shin, right? not the foot. And here is also, it's the target is actually this one. But it to no avail. We could also use a different parent here. Maybe we could try. Sometimes it can even parent this one to. Really, there are many ways to do this. I still. It depends. You need to do whatever works. The problem, not everything works. Let's try this one instead. So, okay, it's not this. What we need is to make sure that in this rig I cannot control the foot like this separatedly, right? So this maybe actually makes sense, but we see that this bone is not reacting, right? We could target directly the control toes, but I want to avoid this because I want to use this structure. So we're gonna try here something else. Yeah, parent. Directly to the deform, and we're gonna target toes, right? It also doesn't work. Target upper arm, target forearm, target shoulder, target upper arm. Yeah, so how about this one? Yeah, still target foot. Yeah. Okay, let's recover this parenting. Okay, if we pose directly the mechanism, then it automates, but when we pose here, it doesn't automate. So this is just what we need to find out. So maybe here we would need a transformation bone constraint. Yeah, because it's something, it's related to the foot or some angle with the foot. So maybe this is why this one uses. So we're gonna try this. You see how weird that is. So we're gonna override it. Yeah, let's override. So it's the same here, but we're gonna change the target to this, and now we're gonna keep this as just a basic thing here, and then we are gonna do this 1/3 thing, and now we're gonna test, and it doesn't activate. Still nothing. So why it doesn't? So here, but it still activates with this. This one is paired to the control tools. And this has nothing to do with, yeah, with the automation. So I believe I need to change this parent maybe. Already tried and too little of it. Let's parent here. Or let's just parent. I already tried this, but this one I never tried, so I don't know why it is negating this setup, even the transformation. Let's try the other way. So it's gonna reuse this. We still want this one. Yeah, nothing is it's not affecting. And here it seems that this, yeah, this does the job, but I really don't know here how this can be adjusted. So if I add another layer, maybe it could be, or it's something about this parent. Okay, target. Let's see. Well, what about this one? This one, if we rotate here, it also doesn't work. So it's not responding to. Let's parent to the target here, okay. And it has the copy rotation tools, try to invert, but it to no avail. But if we pose these, then it works. Okay, so this is like the, it's a control rig problem, yeah, basically for the automation is that this parent is not enough because the automation is coming from bone constraints, and the parenting is not necessarily negating the thing. Let's unconnect here. Yeah, so it's not that the parenting is negating. Sometimes I believe it's the case, but in this case, it's just that this copy rotation, it intakes the parenting relation of the, no, it intakes the immediate posing of this, but not the the non-immediate of this, because this is a parenting relation. So a way to fix this would be to, I don't like this, but maybe that will be the solution. We gonna parent this target foot to Wait, when did I parent this? This is incorrect. So we're gonna parent this to I know I can't do this. Well, whatever. Let's parent this to there, and then make this bone access this control through a copy rotation, pure rotation override. So here now when we rotate the controls, let's see if it also works from auto IK. Yes. So now you have this bone is absorbing the bone constraint, the constraints pathway for this rotation, and so that allows the automation of this bone to work, even though it has no parent. But we could now parent it to, let's say, so maybe it doesn't do anything. Let's try here. We'll see if there's any change. Yeah, so this doesn't, the parenting, right? Well, no, it's still working, right? All right, so it still works. It without the parenting, it moved more, right? So this is done. And as for this one, we can just parent it here, but we need to, why it is moving like that? Because there is this, yeah, so now it's reacting because of course this bone has this copy rotation. And of course, if I parented this with the same bone constraint to the control, it will do a double diff transforms, which no, it's just overriding, but then at the same time, then we lose the, yeah, so it's kind of, it doesn't work, right? So this works, right? So we're just gonna keep this. As for this, the rotation here, I believe this is correct, because if I, yeah, it's trying to move out, right? Move away, so this is probably correct. And then if we move in the other direction, rotate in the other direction, then imagine it will be, I don't know where, straight where, but we can just see here. Yeah, it is the angle is forming here. This is what we need to see. And so this is with enable, it is trying to make space, augment the angle, so that is correct. So we made this correct with just using the copy rotation bone constraint, but we had to create this creepy thing here for all right. And now we can get there's one more thing on this part, is that what about this thing, right? Yeah, like there's a part here that doesn't benefit from these toes, right? Maybe I could ignore, but the fact is that, yeah, this bone has indeed some effect on there. So the idea here would be to do the same system, right? Similar system. This rotation target toes, should it? Yeah, let's first use this here. Let's see if we can. Yeah, this won't work actually because we need to. It's not because of the bond constraint itself, it's because this one has the same problem. So we're gonna also do the same thing. We're gonna parent this to this higher hierarchy mechanism, and then we're gonna make uh, this one duplicate this thing, right? And but change the target here. And so now when we pose here, this also has this additive transforms, right? Whichever the toe that we pose. So this is like just an adaptation. I don't know if this is a good idea, but it is worked, right? So you can do this with bond constraints. You can't do this with parenting because parenting is very stiff. Besides, there is a motion for the z-axis, so it's the whole rotations on that plane, z-axis plane, but not the y-axis. This is different. We don't have bendy bones here, so we are gonna ignore the like the twisting feature, although it probably would be good to have in some in the structure for that, right? Okay, but the foot will rotate like this, right? Anyways, now let's okay, this one seems to be working, right? And then we need to do a similar thing with this one. So I think it's the same, right? It should be similar to this one, and it looks that it is. So that means that if we pick this bone, let's say here, you see that the bones seem to be, yeah, it goes the opposite way apparently, but what it means is that we are making, as I augment this angle between the big toe and the the front of the foot, right? Then the chest of the foot in Portuguese, then this will drop. And oppositely, then if we make this angle here, then these bones, they try to reverse that. Right? So this is absolutely correct. And this is stackable according to, they are delaying, I guess. Yes. It's hard to see here, but we need to make the last revision. Let's see. Yes, this one is delaying and that one is trying to escape. And opposite here seems to be true. Yeah. It's sometimes it's very hard to visualize, but I think that here I got it. And to complete, I really don't like this setup here. Not for nor for the control rig, nor the mechanism rig, nor this helper bones here. It's just very crazy, but at least it's working. I want this I use just for the joint, right? The joints, right? So we're gonna pick one of these, and we're gonna bring it to the yeah. Gonna reverse that. I don't know the parenting here. This parent is to the target shin. So in this case, it should be, gonna move this to the limb triple float. Okay. Where's, No, actually, no, wrong. This is actually the fan structure. We parent this to the shin equivalent, the forearm. So then the bone constraint that we have here is to the target shin, but it will be actually to the target forearm. Then we have local space. Okay, apparently that was tested. We are gonna wait. What is this? Okay, so this is a very specific development. It's not as the other. This one is very special. So the z-axis is pointing the front. Okay, so this is not the front, right? So actually we need to, I believe the rotation here would be, yeah, I believe this roll would be something like that. This bone has, yeah, and towards the front, yeah, the knee would be here, right? So that should be this. And to see if that works, we need to pose this. Yeah, so this is sticking out, but there's no wave here, and we need to change here. So instead of knee, we're gonna change to elbow, and we're gonna erase those strip characters and target forearm. Okay, so why it's getting all this displacement? Maybe I got, yeah, from the X, this is accurate, but it's not going in the right direction, right? We need also to adjust the waves here. I'm gonna pick some yeah, so in this case I'm gonna make something like, to take this off. It's very hard here to, okay, let's just paint all this first. Very artificial, but that should work. and for some reason it's doesn't seem to be doing the right. I was wave painting the wrong bone. Yeah, I was. I can't go back. Okay, but this is easy. Let's see that I was wave painting the other one, the knee sharp. So okay, so it has wrong names again. So I don't know what happened. So what happened to my soundtrack? Let's return. Okay, now this seems to be working better. Okay, so it's pulling that elbow outside, but it's not getting the proper centralization, right? Maybe because I had a driver somewhere. Yeah, there's a driver here. Would like to have, and this didn't actually solve too much, right? I even have a animation test here. I'm just gonna delete these things. So I believe this is solvable without the driver. So maybe we can do the following. We need to make this bone align with this angle on the opposite side and make it grow maybe from here I don't know what will work, but to make it align here, there's a driver that can do this, but I would like to try to achieve this with solely bone constraints. So maybe I keep this parenting. course, it's stacking the parent. It's making, yeah, it's already rotating. And there's already, it doesn't need to be perfect, right? It has already an orientation here, which is not the ideal, but there's nowhere to. Okay, and then I want to make it rotate. Stacking the rotation, right? Maybe here's a question of not here. No, this doesn't seem to solve anything here. Also, the order doesn't matter. Well, it's not that bad, but then we have this thing. See, it grows in that diagonal, which is not that interesting. Okay, maybe this is better, but it's very awkward. I don't mean the deform, but the way it goes. And the thing is the rotation, right? This add, yeah. Yeah, to be fair, this rotation doesn't matter, because what matters is the alignment it understands in the end, yeah. This doesn't change the orientation here. Very interesting. So it helps very little. It's like this bone doesn't require anything special. But I would like it to be oriented correctly. So still a mystery how to solve this without the driver, right? Even with the driver, it's not sufficient. So this one. I think that I solved that thing with just hold on. The driver does nothing. Yeah, this driver is doing nothing for some reason. Okay, so I'm just delete this. probably to solve this we need we need a system, a setup that will be pointing, adaptive pointing. Maybe we'll need some, I don't know how many bones. It's challenging, but it's like it's, if it's not too easy to, it might not compensate. This is an interesting one. I think a lot depends on the parenting here. Let's target chin. Let's try it differently. Maybe if we parent to the basic, yeah, then we have a different thing, right? Not sure if this is better, right? But the bone has the Z-axis, right? So maybe I should try that. So negatively instead of, yeah, so something like this. Yes, it's a fairly adaptation. The bone is still sticking to the wrong strange orientation, but that seems that kind of make it okay. That seems good. Let's symmetrize this. No driver, so this is already some improvements. And as for here, we're gonna move this towards the set of target forearm, target upper arm. Max, maybe I should expand this. Yeah, and same here, the negative. No, oh, here we go. I think, no, never mind. I thought about dumped track negative, the negative, but there's no pointing here. There's a way, yes, if we have a pole target automation, yeah, a bone that draws here, we could use the center of that bone as a center target to align this. Don't just make this slight rotation, like not really not necessary, but it would make things a little better maybe. But I don't have this set up in this rig. It's a simplified control rig, so that I'm satisfied enough with this. Now just for this systems we need, yeah, still not over, so a lot of stuff. So here we have this automation seems to be working. Yes, here it's the rotation. And as for this, same thing. Yeah, so here it will do the opposite. So this. This now doesn't seem to be. No, it is doing a lot. So that is working as well. Yeah, so these ones are very straight. So here is the last remaining thing. I just need to verify. Target upper arm. Okay, using the same target type, target type. Yes, this seems to be correct. The fact that they are displacing like that is confusing, but it makes their joints, because it's normal, because they are following the joints of the target rig. So, but they are doing their job. Yeah, they are derotating, lagging behind. That seems to be making the correct angle. So they are perfect for me. They are working equitably. So we have completed one more of this. I don't want this one. And so here, this is not for us here. So basically, there is just the leverage system set up which exists, where there will be the physics bones, but they are not actually in place. So the fan is ready. I thought that would never end. So here, yeah, there is this crotch setup, but I think this is already working. Yeah, it's working. No need to do anything here. The leverage system, right? So the way it works is that we have certain deformed bones here, like upper thigh essentially, and then lower belly, on the front, on the side, and on the back. We could have one inwards, and this, because of these ones are non-deformed bones, but they are I hope I was not messing up with those things. So the roles are very important here, and the orientations, because this is a leverage system. This adapts because of I key stretch, and you can change the amount of I key stretch for each one of the bones, and some of them have. So this is very tricky, but so you can play with the stiffness. So the rolls are very important for these bones. This we don't touch, but they actually can be. Let's see, what is this? Not using anything here. But if that was a copy transforms to, I don't know, if we want this to move in sync, I was considering maybe mix them all together, but I'm not sure. This will probably break the setup because of the way the bones they were positioned in specific ways. But I was considering maybe in the end. Okay, I'm gonna save here. Let's do something crazy. This probably was placed like this on purpose, not like this. The problem is that I will have to do, if I want to merge everything, I would have to. Okay, let's get this one. So I'm gonna delete this. This doesn't seem to be having any functionality right now. Yeah, for some reason, maybe this doesn't exist. Yeah, we're gonna. Oops, actually, this has transformation is this side. Okay, let's ignore this, and we're gonna get everything to merge, right? But this means that you have to change the target for each one of them. So in this way, this is a more economic rig, and we can also do all this, right? It probably will work. It will be less less versatile, but it will be more economical. The results should be the same in terms of the automation. So well, it's more about how we handle the, which I don't want to get into because it's really time consuming, but you see the results are quite solid. You see how the bones, they adapt organically. It's very interesting. They reshape, they do everything. So this is a so here it's an edit mode, really. Yeah, let's just save here. And so these are the highly stretchable bones. Usually this also use like a stretch, and it's all about the, you need to know the roles. So and this orientation is particularly important because then you know where it's gonna collapse, that bone, and if it will collapse until the very end. Like here, you see that this orientation decides where the bone will collapse, to which direction. And if they will collapse totally or not. Alright, so we're gonna, this was approved, we were able to simplify, this is very good. Then we symmetrize here. One was lacking. Okay, I don't know what is this one. Okay, they were all symmetrized. Okay, so you see this also works very good. I think this is a very good setup, one of the best I've made for this, and we can also use this for the shoulders. And in this case, for some reason, they are not being collapsed in a single, but yeah, I see this provides more versatility, more possibility, but it's also more complicated. So I'm gonna keep them like this and just see what they are doing here. Yeah, they seem to be working fine. So we're gonna keep this setup like that, and maybe just changing these sticks here, these two sticks. And I think we have some physics that which have different have to check if this is working as expected. No bone constraint here, alright. Yeah, there might be some problem here with this leverage. This doesn't seem to be. Maybe we are missing. Well, there's no physics here. Okay, so I'm gonna ignore this, but we're gonna just take, okay, we completed this, so don't think it's because of the lack of physics. Maybe it's because I need to check. I don't remember in particular that problem being so bad. So it's probably. Alright, so we completed the challenge here, my own challenge. So basically, folks, I'm gonna start doing something different now on the project. Maybe we're gonna keep doing these lives, sharing the progress on this custom rigging for skinning, organic rigging Blender, but reviewing what we are building with the team. That might be an interesting topic, right? Subject for this channel in the current times. But I'm not sure I'll have all the time for doing those things. My idea with this collaborative project will be to do this like chilling experience, chill out, right, with fellows which are passionate by rigging and humanoid characters, whatever, in Blender, making those stuff for 3D animation, and also 3D animation. Some are also interested in the control rig, which I'm not really addressing right now. So this will be ready, this file, but just for the participators of the team. The character design was changed to something more or less. Yeah, it's not exactly my character design, so it's just. It's not Dorothy, right? It was Dorothy, so we need to. I removed the textures, the clothing, the hair, the lot of stuff, right? Maybe these eyes I forgot to remove some. Yeah, let's use it as a. Nah, let's remove this too. Okay, so there's just whoever is free to do whatever they want with this. Alright, we need to sort those new material here, right? So this is a shame. We'll leave it like that for now. And I just want to make sure that we can purge these things, right? Okay. That's it. So we're gonna just get this ready and let's see, get to this point here. Yeah, okay, this is still working. We say that we have still this problem that is unsolved in this rig, but if I solve this backculling, then Okay, so that was it for today, folks. Thanks for watching. Take care. Happy blenders here in the weekend, I guess. Good luck on your projects.